Hi, in this video I'm going to talk how to select the value of the input-output capacitor. So this TLV755P require a minimum of 0.47 microfarad effective capacitance on the input and on the output. So why to use X7R or X5R? Because these ceramic capacitors maintain stable capacitance and low ESR across temperature and voltage change. The ceramic capacitors lose capacitance when we apply voltage to it. And TI suggests their rating, which is here, by 50%. And that's mean if we need 0.47, then we have to use 1 micro nominal capacitor or bigger. Let's see how this DC bias work in the real world. So let me open this. So here I just wrote in DG key that I need a capacitor, and then I can select the value of the capacitor from here. And here I can choose X5R or X7R capacitor. Then it will show me all the capacitors on the values I need. Of course, you have to pay attention to the voltage rated. It should be at least 6.3 if you have an input 5 volt and so on. So now I have selected from the filter 2 capacitors with 1 microfarad. So this is for X5R, and this is for X7R. And let's see how to define this DC bias we talk about. So if we go to Murata website, since these capacitors are from Murata, if they are not from Murata, you might find some tools, or you have to read the data sheet of it. But Murata offer us a nice tool if we go to products. And then design tools, online version. Then we have this online version here to choose our capacitor and see the DC bias here. So let's start from our first capacitor, which is the X5R. And let me copy the manufacturer part number. We paste it here. Then this is our capacitor, 1 microfarad. Then we have 25 voltage and X5R. So to see the DC bias, we click here, capacitance. We have to select it, and then so here it will open the graph, this graph. So we can see in this graph at 0 volt, the capacitance is 1.082. I can make it a little bit bigger. And then when we also increase the voltage, so if we have, let's say we have 3.3 volt, this capacitance, it will be 0.628, which is still acceptable compared to the data sheet, because they mentioned it should be at least 0.47, but we normally choose bigger. So if you remember this value uh, on the on 3.3 volt, the capacitance value is 0.6. Let's compare it with the other capacitor we have with X7R, which is this one. So if we clear the options, close this, and we put the other capacitor, DC bias, capacitance, then we make it a little bit bigger. So let's go to 3.3, and you can see on X7R on 3.3, the capacitance is 1 microfarad, and that is much better than the X5R. So when we apply a voltage to the capacitor, it creates electric field inside the dielectric materials of the capacitor. In X5R, the dielectric material is less stable, and it's in X7R, the dielectric material it's more stable, and that's why we can see also that X7R is better than X5R. So we can choose in our design. I prefer to choose, for example, 4.7. It doesn't hurt. I don't like to go to the edge. So we saw this problem here on our X5R and X7R as well. And also, if you need in the future to apply more voltage, your design is not going to work even if you use X7R with 1 microfarad. And that's how we basically select the capacitor. Thanks for watching.